Welcome to our today's session. This week we have a long week, so we have a session on Saturday as well. This week, it's quite nicey week, but hopefully at the end of the week it will be better. Okay. So hope you can hear me well. Things fine, and then we can proceed. So the plan for today is that we start. I checked your answers on Knowledge Check 2. I'll share the results maybe a little bit later today. I have the list. I can share it later. But before that, let's go through the answers. Let's go through the answers and see what was wrong, what was correct in your on your answers, on your answers. This is the first thing. Second, we will go through the solution what we discussed. You could implement last time to adjust the array store calls to be able to add the elements to the array with unlimited capacity. So we can check some possible solutions there today, and then we also have one presentation. We'll go through the delegates and delegates and the events today. And also I guess at the end of the session, remember next session is deadline for the next home task for activities 6, 7, and 8. So maybe I will give you time at the end of the session. You can finish the activities. I'll be here so we can discuss if anything is not clear, and then on Wednesday we can discuss the solutions on these 3 activities. Okay, so let's start then. So first of all, regarding the tests, let's go one by one and make the questions clear here. Okay. So the question 1 was just coding this new version of Microsoft Word. It's okay, it's fine. It's just so this new version is a little bit crazy. Need to get used to it. On these full screen modes, can I just simply hide? Oh, come on, Microsoft, what do you do? Come on, just hide. Okay, crazy. So first question was just simply to follow the logic, the sequence of the steps. So we check method 1. So here we have method 1, and so we can check the steps one by one. So first we have the assignment x equals 10. Then we see that this value is passed to method 2. So we can go to method 2. So it means that x is 10 here, and then it will print 2. It will print method 2 at line 14. It will print method 2. It's 10. So we see that such option is not here. So then this one is not printed. So there is no such option. We do not highlight, but it should be 10 since we see 10 is passed here and this passed here. Then here we reassign x 50 to x, and then this one's printed. So it prints that method 2 x method 2, x and x is 50. So this one is correct, and then this one is executed. So execution of this is over. We go to the next line. Then this one is printed. So we see here x is 10. So it prints method 110. Yeah, so there's no such options. So we skip this. Then we see x is 20. 20 is assigned to x. Then it prints method 120, and then this one is executed. Yeah, oh, sorry, 20. Yeah, this one. Sorry, 29. So it means that this one is correct, and yeah, it means that B and D are correct. I guess everyone of you answered this correctly. But the question now is for you: what will happen if this one is changed to reference? So the question is, what will be printed here? So check question for you. What will be printed if this one is changed to ref? So if x is passed by reference, what will be printed here? 27. Question to you. No? No answers?
Method 150?
Why 50? Where to? Ah, yeah, that's correct. Yeah, that's correct. Method 150. Yeah. So yeah, x is assigned to, yeah, since it's passed by reference. So remember, if we pass by reference, then the value is reassigned. So it means that we just simply use one variable. So the variable is declared here. Then the same variable, then if it is passed by reference, then the same variable will be used inside this method as well. So it is assigned to 50 here. So it means that the value still stays assigned to this x variable. That's why it will be then 50 here. Yeah, correct. So then in that point, the first line would be correct as well. Yeah, as well. Yeah, and then in that case, then this option would be correct. This option stays correct since x is assigned to 20, and then 114. This one is still not executed then, because of the sequence that 20 is assigned after the method 2 is executed. Okay, so with this one we are clear. Let's then check this one. Yeah, again we can start with the static void main and with the execution of the method. So we go to method 1, then yeah, it passes x holder. So then this one is executed, and x holder, where is x holder? Yeah, x holder is initialized to 10. So then this one print method 110 at line 5. This is correct. Then there is method 2 executed, and then holds is passed there. So we go to method 2. Then we see that it is again assigned here. It is again assigned here, and that means that method 2 will also print the method 2 will also print the 10. Yeah, but there is no such option here, so then this would be skipped. Then here, holds x is assigned to 15, and then this one will print method 250 at 114, so this one is selected as well. So then method 2 is executed, and we try to execute x here as well. So the question for you is what is the answer here? So what will be printed here in this case? Remember that we changed the value here, then the reference is used. So here is the idea that we use the references. So X holder is not the value tag, it is a reference tag. So remember, what is the property we have with the reference? So the question for you is, what will be the answer here? What will be printed in this file? So just again, we go NET-2, this object is executed, and we go here. So the question is, what will be printed here? Any guesses? No?
The same thing, method 150, because in the second method it was 50. And as a reference, it's back to 1.
Yes, this is absolutely correct. So, yeah, remember here we talked about pass by reference. So in this case, when we actually work with the reference variables, yeah, so since here we work with the integers, integers are not reference variables, integers are value types, and these are value variables. So it means that when we simply pass integer, it is passed by value by default, and if we add ref, then it will be passed by reference. Yeah, and in this case, when we actually work with the reference variables, then the thing is that reference variables are passed by they are always passed by reference. Moment, actually, there is one difference for the reference variable. So let me imagine the case. One moment, if I'm not mistaken, there was one exception for the reference variables. I don't remember this, to be honest. Okay, I'll maybe think about it later. But I mean, in general, yeah, the idea is that if we use reference variables, then there is no reason we pass by reference. The value is passed by reference by default. Yeah, right. So then, one moment. Maybe give me 10 seconds. I will maybe remember what was that case. So if I just remember I had one case in my experience. It was, if I'm not mistaken, that was related to the exception handling. One moment. Yeah, maybe let's quickly, maybe just also for you better, I can show the example. So let me create a new solution for today. Yeah, I mean, but in general, this is the relevant case that for reference variables, we don't need to pass them by reference. There will be no difference. One moment, let me quickly create console application. That will be demo today. So today is the 6th of December. And so let's go. So. Yeah, let's have a look. So let's say I create the class which let it be circle. I don't know. Just one example, and then the circle would have the radius. Getter, and it has setter. All right, so let's say I create circle. Equals circle. I create a circle as. Oh, one moment. Okay, maybe let's finish this. Yeah, so we have circle. Let's say I have the method. So this is what we wanted to discuss. Static void, and then the method would be we change radius. And let's take the example that circle is passed by. Okay, this is the name of the variable. I can name it as I want. Let's change the circle to radius. Oh yeah, of course. Let's change the public getter and setter. Let's say radius will be 6. Here, wait line. So, oh no, hold on. Let's assign the initial value. Let's assign the initial value to the circle, to the radius. So it will be 13. And I call the method. So I use the object and then I print the radius. Let's execute this. Switch, please. Let's build it. Okay, build succeeded. Now I can change it. Change, and let's see the result. Let's see the result should be 6. Here, yeah, so see that the radius is changed inside the map because again we passed by reference. So if the reference is passed, then we actually work with the same object. There's no new object created. That's why the object stays the same, and that's why the value stays the same. So in this case, I would simply say that if we pass it by reference, the result should be the same. There's no difference here. Yeah, so. And yeah, also we can check one more thing. So if I say there is the object and I create a new circle for this object. And then I change the radius to 8. So let's see what will be the result. Okay, I will skip this one and run the program this way. So here's the interesting thing. Yeah, that was I guess the example I was talking about. So in this case, what we see that the radius is changed to 8. And here the question is why. So a moment, and now let's execute the same without ref. here. What we see here, the result is 13. Yeah, that was the point I was talking about. Yeah. So I mean, in general, you see that there's no difference if we provide or do not provide reference for the reference variables. But the thing is, when we yeah. So now, what's the difference between ref, pass by ref, in the context for reference variables? We have not discussed this before, but this may be tricky in some cases. Yeah, in some cases to follow the logic. So again, we see here if maybe I will say it here. If so we can check it later. If we pass by ref, then the result would be 8. Else, just make shorter, it will be 13. So, and here is the, let's say, maybe a little bit tricky case for the reference variable. So the thing is that, imagine, what did we talk about reference, pass by reference for the value types. For the value types, remember, we pass the value plus we also pass the variable. Yeah, so basically pass for pass by reference, we pass the value alongside with the object. Alongside with the variable. So basically, we just push the whole variable with the value assigned inside the method. This is what is how pass by reference works. So we basically push just the whole variable like we have here. We push the whole variable inside the method. So it means that this variable will then be used. And what we see here is there is no new variable created. It still stays the same variable declared here. So you see here we declare the variable, the same variable is used here. And then if the value of the variable is changed, yes, so we want to point out the value of the variable is changed. So in this case here, I suggest you to follow the terms. Here we assign a new value to the same variable if we have pass by reference. Yeah, we assign the value to the variable. And then it means that, but remember, if we pass by reference, then the variable still stays the same. So just imagine that we take this circle variable, put it inside this method. So for this circle variable, there's no difference if the value is changed here or the value is changed here. It's still the same variable. Yeah, in all these cases. But, and that's why if we assign a new value to this variable, then of course then there's the new reference that is stored under this variable. Yeah, so this is the thing with the pass by reference. But if we don't use pass by reference, like if we have in this case, then there's a new variable created. Yeah, so object is still the same. Yeah, if no, let's pass by ref, then the new variable is created. Yeah, so this is the point. New variable is created. And what we do, we only pass the reference of the object. Yeah, it's not passed by the reference of the whole variable, but it is passed, only the reference of the value is passed. Yeah? And the value is reference type. Yeah, so basically, in this case, we only pass this new circle created here. Yeah? So this creates the object, the reference of the object. It is assigned to the variable. Then again, the variable goes here, and then we don't pass the variable, we pass the value of the variable. And that's the difference. If we pass by reference, then we pass the whole variable. If we pass by value, like we have in this case, we only pass the value of the variable, which is circle. Yeah? So we only pass this circle. If we pass by reference, we pass the whole variable. And that's why the results are different. Yeah, because in this case, if we don't have pass by reference, then it's simply it is a new object created here. That's why the object assigned to the circle here is not the same now as the circle created and assigned here. So these are two different variables. Here, object and circle are now two different variables. They're not related with each other. The only thing in common they have is that at this point the references is the same. The references are the same. The reference of the value. So is this point clear for you? Do you have any questions? Yeah, this is a tricky case, and at some point in practice you may need to follow if the value is passed by reference or the variable is passed by reference or passed by value, because this may impact your result. Yeah, so this is tricky, but this may be important. Okay, and yeah, one more point what I wanted to, okay, maybe I will discuss this later for, yeah, maybe let's discuss this a little bit later. I wanted also for the out variable. And yeah, maybe we can discuss. Yeah, maybe for out we can discuss a little bit later. But yeah, for this particular case, if you have any questions, let me know. No? Okay, so then we are clear with this case. And then there was the theory part, which was a little bit tricky, I would say. So the first one was, is it possible to use only try finally without including catch statement? So the thing is that it is possible. Yeah, in this case it will trigger finally instead of catch in all the cases. So for this case it is true. Second one is if there are several exceptions that might be thrown after single try block statement, it is possible to have multiple catch statements to handle them. Yes, it is true. We can always use the try catch one exception. So that would be arithmetic exception, if I'm not mistaken. Yeah, arithmetic exception. And so we have some catch here. Then we have another catch. That would be parse. What's this? Some exceptions. So yeah, we can check some exceptions. Say argument exception. And then create another catch here. We found that thing. Skip using the variable. Yeah, this is the variable with the information about the exception. So yeah, we can make we can use multiple catch statements after one try. So, but there is one point. So the point is, if I try to do it this way, then the compiler will compile. Why? Because actually there is no, like, if I catch the exception on the top, there is no reason for me to catch the exception of the subclass of exception, because remember that exceptions are thrown in the way that all the I mean the same as in object-oriented programming, same as in the inheritance. If we have superclass, so in this case for the exceptions are all the classes. So the rules for them are the same as for all the classes we have, and it means that they also have this is a relationship. So it means that all the objects declared as the subclass, they all are also the objects of the superclass. So they have this as a relationship, basically top-down design. And that's why it means that all the exceptions of the subclasses will also be thrown by the superclasses. Yeah. So it means that in this case, argument exception and all the exception classes are the subclasses of the class exception. And then it means that if we have the exception of the superclass on the top, there is no reason to define the exception of the subclass down. Yeah, because exception will catch all, and exception will catch all the exceptions, and there is no reason to declare further catch blocks because they won't be reachable. Because again, in this case, I will try, any exception is thrown, then this block is executed. This block will never be reached because the exception class is the superclass of the catch block here. But what will happen if I do the opposite way? So I firstly catch the exception, which is the subclass of the superclass. So this will be correct because in this case it will work in the way that the logic inside try is executed. If it throws argument exception, then this part is executed. If it throws any other exception but argument exception, then this catch is executed. So basically it goes like if the exception is any exception is thrown, then it goes through the catch statement and it checks, is the exception thrown argument exception? If yes, this part is executed. If no, it checks further, is the exception thrown? Is it an exception? Yes, it is. Then this part is executed. So here we have this pattern, this sequence. Yeah, we check the first catch, then we check the second, third, and so on. Yeah, we may have multiple catches here, and they are simply checked one by one. And if it's the same as if else if statement. So we have if exception, like we go here, exception is thrown, then the type is checked. If exception is argument exception, yes, we go inside. No, we go check next statement. Else if exception thrown is exception, yes it is, and the exception is it's like the same way. Why we can't do this is just simply because if you have, let's say, integer a equals 5 or a equals 4, then if I say if a is greater than 4, then do some stuff. So say something happened, and then else if a is greater than 3, then we'll do some stuff. Yeah, so in this case, compiler is a little bit, say, stupid, because it does not see that if a is, oh, sorry, no, hold on, the opposite direction. No, hold on a moment. Oh, sorry, I'm a little bit confused now. So if a is greater than 3, so it's not 2. Yeah, in theory, I can also repeat the cases, and in this case, yeah, I can also repeat the cases, and I see that if a is greater than 3, I can also repeat the same check here. Yeah, it doesn't make sense as well. Yeah, so because in this case, two cases are just simply the same. Same as here, if I have exception on the top, then basically the, oh no, hold on, I can say, yeah, maybe let's check another thing. So in this case, if a is less or equal than 3, I mean that would be more correct. Yeah, so in this case, I mean I have the same thing. This part is unreachable. Unreachable because, like, if I check if a is greater than 3, this will be executed, else this will be executed, and then basically this code will never be reachable, because under these two statements I basically check all the possible cases. Same as here. Here I check all the possible exceptions, then this part is unreachable. And so this is understandable by compiler. That's why it is relevant. Yep. So do you have any questions about this particular case? Next. So the next one was if there are several exceptions that might be thrown after a single try block statement. Oh no, that was sorry, that was done. Next one. Next one was a little bit tricky. This was a little bit tricky, and basically here I can say it can be true and can, so it can be, but we can say, I mean, it depends on how you look at it. So does throw statement reset the information about the call stack? I would say not. I would say, but it resets under some point. Yeah, I mean, it does not clear it totally at all, but it resets it. So basically, what does it mean? Let's have a look. Let's have a look. So here I have the logic. So I do some thing here and throw the exception. Throw the exception. So let's say just an action here, or maybe I'll just simply throw the exception without any actions. So then this one will be executed. So let's say I call another try catch. So basically here I have inner try catch, and here I will call the exception, and I will print the information about this exception. So, and let me call the throw. So basically, let's check the results. Let's run this. Yeah, so we see that information about the stack, we can check it here. So it says that it comes from the program line 28. Yeah, so program line 28. Where is this? This one. Yeah, so basic, maybe just to make it more interesting, let's run it and leave it there. So that was, I would say, maybe a little bit tricky question, but let's, yeah, sorry, let's run debug. Debug. Okay. So now, okay, let's enable it. Oh, let's go now. Okay, let's run again. Let's just. I don't have the test here. It doesn't come from me. Okay, it looks like little bit. Okay, let's try again. Okay, should be better now. It is executing. Yeah. So the point here is that we go here, and then the exception is thrown. It now goes under the catch statement. So it checks that the exception throw is exception, or the sub clause or the exception clause is true. Then this point is executed. So we are on line 32. But when the throw is executed, we go back to this point. So basically, and then when this catch is executed, now it prints on the screen that the stack is positioned at line 28. Yeah, so basically, but remember, we had the path. Yes, we can close the debugger now. So we have the path from here to here, then we go here, and we go here, and then we go here. But it says that we are coming from here. Yeah, so it says the exception is not thrown here at line 32. It still says that the exception is thrown at line 28. So this is the point when we can say that the stack is reset. It does not say that the exception is thrown at line 32. It is thrown at line 28. So basically, what throw does, it's simply how can I say better? Rethrows. Yeah, so we can say rethrows the exception. Yeah, so basically here we say throwing an exception, then catch statement is called, is executed, then we are here. But here it says this catch is maybe we can say this, that this catch statement is not relevant. Please check for another catch statement. So then simply it says that this catch is ignored. It goes next. Yeah. So this is the point that here we find another catch, and then this catch is executed and we'll write the information about the exception. So here is the point when stack is reset. Do we have any questions about this particular case? Okay, we can move on. So the next one is if an exception is handled in catch block, then the final block is not executed. Well, this is not true. So let's check this. Let's say finally it's executed. Let's throw exception. And yeah, by the way, let's maybe run this. So see that finally is executed. And by the way, what happens in this case? Yeah, regarding the previous point, let's take a look on the stack trace. Yeah, so we see it shows the line 32. Yeah, so here is the difference. So if we say throw, then this it withdraws the exception and resets the stack trace. And in this particular case, it does not reset the stack trace. Okay, so here's the difference. And in this case, still finally is executed. Okay, so this is the point here. So do you have any question about this point? Okay. yeah, then this is not correct since finally is executed. Okay, then we go next. The call stack is the chain of methods the program executes to get the current method. Yes, so this is correct. So yeah, maybe I can click picture program stack trace program stack. Yeah, maybe not trace but stack. Let me check the picture. Maybe not program stack trace but program stack. Yeah, so basically here it is. Something like okay, this one, yeah, this one is the best. Okay, go back. Okay, this one. So just internet is a little bit slow. This one. I think this one was the best example here. So methods are executed one by one. So this method calls this method calls this method, and so on and so on. And this is how the stack trace is built. So we have the chain of the methods, which is then called modifier. That's why we call this the stack method. This is correct. So then the next one is it possible to recover some types of errors? In this case, I think because me who does not really understand this, but I mean this point actually, but recover, no, we cannot actually recover from that point. Yeah, we cannot recover. I mean, I understood this as that we have the exceptions, and then we can simply go back and then execute the same code. No, it's not possible. Of course, we can create a loop or something like that, but just directly we cannot do it. Okay, the next one is at least one catch block must appear after the try. This is not correct since we have this first statement, and we know that we have things finally block. Then after a try block in C#, yeah, so that's one. This one is false, because we can have finally instead of catch blocks. So next one is after a try block in C# can follow multiple final blocks. So that doesn't make sense. It is not correct, since it doesn't make sense to create multiple finally. And the idea of finally is that it is the code which is executed at the end, and of course it should be one. Yeah, we cannot have. There is no reason actually to create multiple finally blocks. That's why this point is false. Do you have any questions about this list? So is this clear? Some points. Okay, so I assume then it's clear. Yeah. Then the next one, and this one was also a little bit tricky, I would say. Not tricky, but a little bit confusing. Sorry. And here I can accept two answers. So maybe for me, most preferable is none of the above. Yeah, because first one is definitely not correct. Programs are based on the concept of procedure calls. They're basically these are two opposite directions of the programming. There is object-oriented programming, the programming based on the objects when we work with the objects, and procedural programming is is taken as the opposite, which does not have any object, it simply follows procedure by procedure. So maybe I can quickly show one schema. Procedural programming, where so if you type in Google, maybe let me try to type this procedural programming. You can see one of the first suggestions is that it takes the opposite as object-oriented programming, and so then, as you may assume from these actions from Google, that these are two opposite directions, so opposite directions of the programming. So we can also take some concepts. If my internet is better, at least a little bit. And so you can see, you can see some schemas, some pictures. So maybe I can also copy paste such image and paste it in chat. So procedural means simply follow the actions. I would say, guess the best example of procedural programming is SQL. So in SQL we simply say, get me this data, change this, update this, delete this, and so on. So we simply have procedures. Do this, do that, take this, take that, and so on. For object-oriented programming, we actually take the whole object and we interfere with the data using the objects. And so that's why the first one is definitely not correct. I mean we can use classes and we can use the concept of classes for the procedural programming. We still can call the methods, like simply print this, print that, change this, change that, and so on and so on. So we can, this would be more correct, using the elements of object-oriented programming, we can achieve the procedural programming. But the concept of object-oriented programming is not based on the procedure calls. That's why the first one is not correct. The second one is objects communicate and interact with each other using messages. This sounds a little bit crazy for me. Why using the messages?
Excuse me, can I interrupt here? I was just, when writing the test, at first I also think that B is incorrect. But after that, I found exact statement in one of your presentations. I wouldn't mention by heart in which slide, but I actually found this,
using,
just the remark. Regarding point B,
Okay, this, I mean, they can interact and communicate using the, okay, let me quickly check the presentation about this. Thank you very much for this notice. Double check this one again. I mean, this can be correct, but so the statement for me it's a little bit crazy.
No, for me it also sounds a little bit weird, but I don't.
No, I mean that's fine. If you answer this, then that can also I can also count this as correct.
I suppose I found something like this about messages also in presentation. Therefore, I chose.
I mean, thank you for noticing this. Because I did this test myself without the presentation. That's why there may be some differences. Okay, here it is. Here it is. Just communicate. Okay, then I can count this as correct, but but that's still. I mean, using the messages. Well, okay, maybe let's just simply count this as potentially correct here. So if you take the presentation, but then I think I can put the question on the presentation. Yeah, I mean, this was taken from the previous presentations. So, yeah, I mean, this point is maybe a little bit confusing. Okay, then I will then mark this as also as correct. Then, yeah, so the next one, I would say also up to you programming organized in fashion similar how we organize. I mean, this can also potentially be correct. Why not? Since we deal with the objects, you know, I mean, the question is what you consider, what you understand by saying fashion. So, I mean, okay, if you want, this can also be correct. Fashion, similar way. Yeah, maybe, but I mean, also this sounds a little bit strange, and none of the above. Yeah, that would also be correct. But so if you answer B or C, then we can count this as correct. Okay, then I will check and maybe add some points, but, not some points, but the point for this. Okay, then do you have any questions about this strange question? It was maybe a little bit strange. I'm sorry, but okay. Is it much that you noticed this from the presentation? I don't remember all my presentations by heart, so that's why. Yeah, thank you very much. Okay, so then yeah, I'll recheck this. Yeah, then let's check for this one. Next one, match the concepts to the right, to the objects on the to the terms on the right. So then the first one is the ability to hide the internal implementation details of an object from its external view. So this is definitely encapsulation, since we, as I said, we take the data, where we take some behaviors, we wrap them inside the object, we get the object, and we call this concept as encapsulation. So we take something out, so it stands from the name, put inside the capsule, and gets the hide the data or the methods, so we can hide them inside the capsule, which is the object. Yeah, so this is then B. Second is the ability to create new classes based on the existing classes, so this is inheritance. And so yeah, one class can inherit from another, inherit the properties from another class. So yeah, I can say inheritance, inherits, extending would be, yeah, extending would also be correct. And I even say extending, inheritance. I would say extending would be maybe more better. I prefer extending, since we'll talk about it this week, about the best practices, and then we will cover this topic, and we'll see that basically I guess you all know that all the subclasses should be extended from the superclasses, so they have all the same opportunities as the superclasses have, plus they have something more. So in this case, we say that we extend the functionality of the superclasses using the subclasses. But yeah, so inheritance is still correct. I would also say the extending would be maybe a little bit more precise. Okay, but this one is correct. Then D, next one is object's ability to behave differently depending on its type. This is what polymorphism is about, since we can say that the animal can behave as lion, and then the animal can behave as the elephant, for example. Yeah, so the variable still is the animal, but then it can be elephant, or it can be a dog, for example. Yeah. So the animal can have multiple assignments under it. So then this is entity, and next one is a self-contained entity with attributes and behavior. So this is the object, because the objects, they have the methods and the attributes, so they have the properties and the methods which can work with these properties. Okay, so do you have any questions about this fifth task? I guess that was pretty much straightforward. So, okay, if there are no any questions, then we can have 10 minutes break now, and then we continue with this. So what's the minute at that would be 7:30, so 7:43. Okay, so maybe 10 minutes. Okay, so let's continue. And let's go to the next question. So the next question is about the constructors and which statements are correct. So first one is base class constructor remain as constructor also for derivative class. For the sub is true. And yeah, in this case, I don't really like the term derivative because usually we say that derivative is something something a part of the element which is cut. So maybe also for the subclass, I mean that more precise. And yeah, this is correct since again, remember we always need to call the constructor for the of the superclass if we want to create the object of the subclass. This will always be correct. So this we always need to call the constructor of the superclass. Right, so this is why this one is correct. Again, it's up to us to decide which constructor we want to call. Like if we have class base, I have, let's say, two constructors. So one constructor is simple, another constructor is parameterized. So something like this. Then from the subclass, I can decide which constructor I want to use. Yeah, I mean by default, base constructor will be called since it is not parameterized. So and then I can say okay, I don't want to match base constructor with one parameter called. So and then if I create the object of the subclass, let's comment out this code, don't need this. And I can create the object of the subclass. Remember, I can cast. Let's do the superclass. And then you see that the unparameterized constructor of the superclass will be called. So it will be called. And if we can also redefine the constructor here. Then again, by default, and then I can write one here. Constructor of the subclass called. And we see that now both constructors will be called. And so even despite the fact that I have not called it directly from here. And so by default, non-parameterized constructor from the subclass will be called of the superclass will be called in the subclass. However, I can also call the parameterized constructor, and then parameterized constructor will be called. Yeah, so by default, I have the base. I have the here, just I added semicolon. That was the reason for the error, compilation error. And if I select to call parameterized constructor, then parameterized constructor will be called, and non-parameterized constructor will not be called. So basically, I can, in the subclass, I can decide which constructor I want to call. By default, it will always be non-parameterized. Otherwise, I can select parameterized constructor. And parameterized constructor, remember, they cannot be called by default. So in this case, if I have only parameterized constructor, then it means that I can create the base class only using the parameterized constructor. So it means that here I need to call, it's mandatory that I need to call this parameterized constructor, otherwise the program will not be compiled. Again, because subclass should always call the constructor of the superclass. Yeah. So that's why. And if constructor is parameterized, then the program will not understand how to call it without. I mean, like if the constructor needs the parameters, then program cannot just simply call this method automatically, right? Since the program does not know what are the parameters you want to pass there. But if the method has, if the constructor has no arguments, then the program can easily call it without your notice. So that's why this first one is correct. Second one is constructors can be overloaded. Yeah, this is what I showed here. That we have parameterized constructor and we have unparameterized constructor. So this is what we call the overloading. Yeah, remember, overloading means that we have the implementation of the same different implementations of the same method, which has different parameters, different signature of the parameter. So here the signature is no parameters. Here the signature is one integer parameter. Yeah, that's why this is correct. Constructors can return value. This is not correct. Constructors have no returning type. Yeah, because by default they always need to return. Yeah, actually, in theory we say that they return the instance of the class. So this would be correct, but we cannot define a separate value to return. So this is not correct. And the next one is constructor name must match the name of the class. This is correct, and this is simply how the constructors can be defined. So if we provide the name of the class. All right, so are these points clear? Do you have any questions about them? Okay, hope it's clear. This point was pretty much, I hope it was pretty much clear and straightforward comparing to this point. Okay, so let's go next. And next one was about true or false statements about the method overloading. Yeah, again, remember, overloading means implementation of the same method with different argument list. Sorry, with different signature of the argument list. Even like, and the name does not matter. If we name the parameter int a, then I cannot create another method or constructor. It doesn't matter with the parameter integer. Yeah, I mean, compiler does not care about the program, does not care about the name of the variable. You can call the variable as you want. The problem is not the problem, but the thing what the program cares about is the pattern, the signature, and the signature is the sequence of the elements. So if here I have integer a, then let's say I have string b. Then I can not do the following thing. So since pattern is the same, integer string, I have duplicates, but if I change the pattern to string integer, that will be correct. Wait. So pattern, like pattern should, it means this is the sequence. And the sequence of the I would say value types, because sorry, not value types, but types of the variables. That will be more precise. So it should follow the sequence. The sequence can be mixed, but the overloading is based on the sequence we have, on the sequence of the variables we have. Sorry, of the types of the variables we have. So this is what the overloading is about. And yeah, so the first one is our overloaded methods must change the argument list. Yeah, this is correct. And more precise again, as I just said, would be that change the pattern, the sequence of the argument list. And again, don't care about the names of the arguments, but we care about the sequence of the type. Yeah. The types. So that one was correct. Next one, overloaded methods cannot change the access modifier. No, this is that was overloaded, right? Yeah, overloaded. Yeah, so we can have the method which, so let's create an example. So let's say I have like, say, wait method a, integer something, for example. Then I create protected void method a. So then I can have different access modifier, and this would be correct. And so I can have multiple methods with same name but different access modifier. But this does not affect any. I mean, this does not make any conflicts because the overloading is detected on the compilation moment. So it means that during the compilation of the program checks the method name plus it checks the pattern. Yeah, and then if the access modifier is not public, then the access to the method would be restricted, and at the point of compilation, the program will understand if the method call is correct or not, if the method is visible or not. If I do something like this, then this should not be correct, because I may have the cases where I can access the public method and the protected method both. So if, for example, I call them from the method inside the class, I can access both methods, and then compiler will not understand which of these methods I want to access, since they both have the same signature. Yeah, that's why this should not be possible. But for the overloaded methods, I can change the access modifiers. I think some of you could mix this with this case, mix it up with this case, and yeah, so in this case you were right. Yeah, we cannot overload the methods using the access modifier, but we can change the access modifier for overloaded methods. And so this one is not really correct. Yeah, but if it would say that the change of access modifier can trigger the method's overloading, and that would be can't trigger, and that would be correct. Right, so let's go to the next one. Difference only in return type constitute a valid overload. No, for the returning type, and so on. For the returning type, it can definitely not be. So, like, let's say I can return the type. Let's say I return string. Yeah, I mean, I can do this. I can do this. That will be good. Oh, sorry. It's probably, yeah, to return the string, of course. To return the string. So, I remember, if you have a returning type, you need to return this type, or the value of this type. Yeah, so and that will be correct, since again compiler will understand. And if you call this method as void, this will also be correct. It's not mandatory that you need to take the value returned from the method. If you want, you can simply call it as the void. Yeah, all the value, so all the methods with the returning type, they can also be called as the void. So it's not restricted. It can be done. Yeah. But if I have the same signature, then of course this won't be correct, since again the program will not understand what do you want here. Okay, so this is the point, and that's why the answer is that this is false. Okay. So now we go to the next one. Any number of forward lines can exist within the class. This is true. We don't have any limits on the overloaded methods. So are these points clear for you? Do you have any questions?
Yeah, hello. I have a clear question. Can I ask one about before? It was, I think, the theory question. I maybe missed when you explained it, so don't repeat it. The long theory question, yes, this one with what ends with H. And there was one question I actually really doubt about it, because it also seems very general for me. It's about regarding.
Sorry, which one?
It is possible to recover from some types of errors.
Oh,
it's
yeah.
3F.
Yeah.
And yeah, and I really adapted, because at first I answered correctly, and after that not correctly, because I start to think philosophically, and that it should be possible to recover sometimes. Yeah, how it was.
Yeah,
maybe
yeah, I mean, yeah, I also agree that this particular point may be a little bit not really clear. Yeah, and so yeah, sometimes, but yeah, it may also have different understandings from you. Yeah, from this particular case, it is meant as that we simply like we have the exception. Exception is strong. Exception is erased, and then we recover from this place. We go back to this place directly. From, I guess, that this case, at least for me, it sounds like we need to go from catch back directly to the place where the exception was raised. But I mean, there can also be maybe some kind of different explanations. So this point also, yeah, it is a little bit. So yeah, I agree. Maybe what are your thoughts about this point? How did you understand this particular point?
Yeah, I think first of all, I understood correctly that it's, for example, I don't know, someone is entering alcohol shop and writing that he is under 18, and if he gets this errors that you can't get inside, for example, and then of course it's you can't, at least you don't write correct answer, you can't get back from it. Second explanation why I started to think that it's some kind of maybe you can recover from types of errors. First of all, I googled about it, and I think the idea was then what we define as error, and if we define that error is some kind of bug in this whole system, and yeah, maybe I over generalized after that, something like that, and after that you can somehow fix it. If this error is not exception, but it's like, I don't know, you just error as error, something like that.
I mean, this point, it is, I agree that this may also be valid, and for those I checked, when I checked your test, I also pointed this as also as the correct answer. And so, I mean, it depends on how you understand this. So I mark this as correct for those.
Okay, thank you.
When I check this, yeah. So this is, I mean, maybe if you answer it as false, that will also be correct. But yeah, when I checked your test, I definitely also marked answers as correct. Yeah, there's also one thing from best practices from Microsoft documentation. Yeah, so yeah, comparing to other languages, I think Microsoft has really nice documentation. For example, what Java does have, I don't really like this. Yeah, maybe I can just for your comparison, I can show what kind of documentation Java does. Java has. Let me quickly show you one example. You can see the comparison, yeah, because I really like Microsoft documentation. So Java is developed by Oracle, and let me show how the documentation looks there. Yeah, so I mean, documentation is also fine. It's also clear, but I think in Microsoft it looks much more visually. It looks much more better. And so that's why it's, and yeah, Microsoft documentation also has a better and more understandable examples. Yeah, basically, there's this term use today. Come back. What is this? Okay, let's try again. So when I have the sessions, my internet is a little bit slow. Yeah, okay, maybe I can just share this one with you. There was the mention about the recovery from the errors. So use try catch finally box to recover from errors or release resources. Yeah, so I mean, in this case, yeah, if we say we recovered, then we can simply use try catch. And yeah, okay, we can. This point is also discussable, but like it depends on from what perspective we look at it. And so that's why this one is, it can be correct or not. Okay, so but do you have any questions? Yeah, if you have any questions about the previous, you can ask. So if not, then we can move on to the next one. Yeah, this was, guess there were, for this one, there were many mistakes from you, and I think there are only a few who answered this correctly, though this question seems quite easy, I would say. But maybe some of you, for some of you, this was a little bit confusing. So here we talk about the casting. Remember, when we do the casting, we can always assign the object of the subclass to the variable of the parent class. And so this is called upcasting, and upcasting will always be correct. So this by default means that we can always assign the child, the subclass, object to the parent. So then parent, this will also be true, will always be true. and that's why this point is false. By default, I saw that lots of you answered this, marked this as true, but this is upcasting, and upcasting is always valid. You know, we can always assign the child to parent variable. Yeah, so
I can maybe explain why. Sorry, I interrupting, but
no,
explain why because I also marked this C, and the reason was that I was a little bit confused regarding this that for all how to say the mark. Jesus, I forgot English. Irzimek. So it's equal, it's equal, it's equal, and I thought that it can be that parent class can be equal. Okay, that parent class can be equal to child class. So if there would be like two completely equal, yes. So if there would be like two poles, then
this is also a relevant point when we have double equals. Then basically remember that here we talk about the operators, and this is also the not tricky point, but for you to remember that in programming. This means not in programming, but in most programming languages, this is assignment operator. So it means that we assign the value from the right to the variable on the left, and this is comparison operator. So in this case, this would be correct. Like if I have two equals sign, then this would be comparison operator. And then of course, but this will not always be true then, because we can say, let's check one example. So if I have an object here, let's say I have base object 2, and then assign object 1, then I print the result. Object equals object 2. I can run the program. And my program is, again, the breakpoint is triggered, and you see the answer is true. So there are two different variables, but the answer is still true. And in this case, in a moment, I can also do that. So how was this? We child to parent, right? Child to parent. So let's say I create a variable of the subclass, or maybe I can do this way. So just to make it, to don't use the downcasting, I can then do the following thing, and then this would be equals case, and in this case, you see I have the object, the variable of the breakpoints. You see again I have the variable of the superclass base. I have the variable of the subclass obj, and I compare them, but they are the same. They are still the same. So I have the child subclass, and I have the parent base. I compare them, and they are equal. They are equal, and this is because I have basically comparison. It compares the objects. It does not compare the variables. And in this particular case, we have the same object stored under obj2, and the same object is stored under obj. So basically, here we're saying two variables store the same object. The same reference of the object. That's why such case, even if you think about comparison, they still can be correct. This thing can be equal, because they can store in such. I mean, not in all cases, but in some cases they can store the same objects, and then even if we use comparison operator, this will also be correct. But in this particular case, we talk about the assignments, so here we talk about the casting. And remember that parent can't be assigned to child directly, and so if we try to assign parent to child, that will not be correct. Why? Because not all we have this, remember, we have this top-down hierarchy, top-down design, and we have is a relationship. So it means that the subclass will always be the superclass, but the superclass not always be the subclass. Remember, the animal, the wine. So we have the subclass wine, superclass animal. Wine is the animal, but animal can be the wine, but animal can be like the cat or the dog, something like that. And so it goes one direction. So this is the mapping, two-directional mapping. Sorry, not two-directional mapping. So that's why such assignment is not possible. No, such assignment is not possible. But what we can do, we can use the casting operator, and then this will be correct. I mean, it may trigger the exception if we try to assign, let's say we have the subclass lion, but the animal is cat, so we try to assign cat to lion, then this would be the error, because we cannot pass the cat to lion, to the variable one. So that's why we need to use this. And of course, again, as I always suggest, before we do such casting, remember to check this. Or use try catch. Yeah, or do try catch, try catch. And catch would be cast exception, valid cast exception. And so you can check, and as an alternative, you can also use try catch to escape invalid cast exception. And to escape the situation when the object is not the subclass. So yeah, this is this point. This is correct. So this point that we discussed, we can always cast child to parent, since this is the upcasting, and upcasting will always be correct. And since we have this simply by default top-down design and is a relationship, so this one is not correct, this statement. Then the next statement is that we cast child to parent. Yeah, in this case we can simply do the assignment child to parent. Like if we want, we can also do this. This is not needed. Yeah, this is never needed, so this is just not needed, but it can be done. Yeah, because it will automatically be true. So I don't need to use the brackets to use the casting, but this still is correct. Okay, so do you have questions about this? So this is about the casting. This is about the casting and not practice. This is, I would say, used a lot when you work with the objects. So, okay, if there are no questions, we can move on to the 10th. Yeah, which of the true about the multiple inheritance? Remember, in C# we don't have multiple inheritance from the classes. Now, one class can extend only one. The class can extend only one class. It cannot extend multiple classes. Multiple inheritance is not allowed. Yeah, so it is allowed in C++, but I don't know any other language Maybe there are, but I don't remember. At least I don't know any other language but C++, which does allow the multiple inheritance from the inheritance from multiple classes. Yeah, but on the other hand, in C# it is possible to inherit from multiple interfaces. That's why B point is correct. Do you have any questions about 10th question? Okay, then we can move to the next one, and also about which statements are true. So the relationship between a class and its base class is example of has a relationship. This is false because we have, in this case, we have is a relationship. Yeah, so all the objects of the subclasses, they are also the superclasses. Yeah, again, remember the animal is the superclass of the subclass, and the subclass of animal class. Subclasses are cat, dog, elephant, mammal, and so on. And we can always say that cat is animal, dog is animal, elephant is animal, and so on. And so that's why it is a relationship, not has a relationship. Has a would be that, let's say the computer has the processor. Yeah, so let's say one object has another object. This would be has a relationship. Yeah, computer has the processor, computer has the memory card, and so on and so on. Yeah, so this would be has a relationship, but not is a. But when we talk about the class and the base class, it will always be there is a relationship. So this is about this point. And then relationship between the class and the object is referenced by a field with the class. Yeah, so this is has a, again, computer, it has the processor. Computer, it has the memory card. Yeah, but not the we don't say that the memory card is computer or the processor is the computer. Computer has the processor, but not is a relationship. Yeah, has a. Okay, do you have any questions about this? So that was pretty much, yes, that was pretty much clear. Okay, if not, then we go to the next one, and I also remember that for this one, also some of you answered incorrectly. And so, yeah, so this is also the tricky points to remember what are we talking about. Yes, so, and the question is which class is inherited by all other C# classes. So, and from these, the answer B is the only correct. Since remember that all the classes in C# are inherited from object class, yeah, system object class. So that's why all the values, all the variables, they will always have these methods. Yeah, we always have the methods equals, which comes from the object class. We always have the methods. Get hash code, we always have the method get type, and we always have the method toString. These all are default public methods which come from the object class. Yeah. So object class is the superclass for all the classes in C#. Yeah, and also for integer. Yeah, because remember integer, double, and so on. Because remember that integer type is simply integer 32, if I'm not mistaken. Yeah, so yes, it's 32. So when we declare as integer, then we simply declare the structure, which is also inherited from the object. And so basically, all the elements are taken from are inherited from the object class. And so, and yeah, this is object. System is the namespace. Yeah, please do not mix up the the class object and the system. System is the namespace which provides us all the key details, all the key functionality, but object it is the class. Exception, it is the subclass. It is the superclass for all the exceptions. Yeah, so this is different, not different, but yeah, I mean, yeah, this is different, I would say, chain of classes, the exceptions. Yeah, so, yeah, exception is it's just for exceptions. And threading, this is the term for the threadings, for the threads. So is this point clear for you? And yeah, by the way, we don't provide, when we declare the class, we don't provide that. We inherit from object, it is done automatically. Yeah, so it's done automatically. We don't need to provide it manually. Okay, so is this point clear? Do you have any questions? This, okay. Then we go to the next one. Next one is switch of the following is the rule for an interface. So all interface members simplistically have private access. This is not correct because they all have public access by default. Right, so that's why the first one is not correct. Second one is an object of the class can be casted to an interface which it implements. This is always correct. Yeah, and we can say that we have interface int my interface. So then let's say that this class implements this interface, and then I can always say that I can always cast the interface. So this will always be correct. I can always cast the interface. Why? Because interface has all the public members, and we should implement all the interface members under the class. And so if we have, let's say, the method declared in the interface, yeah, where's my interface? Here it is. Then I say that the void my method. So this means that the interface, or sorry, the implementing class should override this interface. Not sorry, not override, but it should implement this interface by method. And so I have the implementation here. It means that I can call this method from the interface variable. Where is it? Here it is. And this method will be available here. I can call it. And so it means that it will call me the method from this object, from the subclass. So this will, again, the type of the object, the type of the object reference stored under this object variable is subclass. So it will go to the subclass, search for this method. Sorry, here it is, my method. Then it will execute this method, and this is what will be done here. Okay. So again, remember the object, type of the object, assigned to the variable. The method is searched from the object type. Okay. And that's why the method is available and then it can be called. Okay. Do you have any questions on this particular example? Yeah, so that's why this point is correct. Next one is a class implementing interface need to contain implementation for all members declared in the interface. Yeah, this is true. If we declare them, because the interfaces are 100% abstract, it means that, and remember that all the abstract methods must be implemented in the class which is not abstract. Yeah, by the way, if we have the case. Yeah, so it's my interface, and we declare the abstract method. Abstract class. My abstract class. Let's say that I implement this interface class first. Then yeah, it still says that I need to implement then my method, even in the abstract class. And let's try then to declare it as abstract. Then in this case, oh yeah, this private. Okay, it should be public. Yeah. So in this case, if you don't want to implement the interface method in the abstract class, you can declare it as abstract. Yeah, so, but you need to declare it some way. Yeah, so this is the point. But when you don't have the abstract class, when you have the real class, then you should implement the method. So that's why this point is correct. Okay, and the last one, an interface can provide implementation for its members, but this is not correct. We can't write the implementation for the methods. Yeah. On the other hand, let's say that we have the element. Let's say the element is x. I declare public. Let's say it could be integer x. I'll have getter and setter. So in such case, yeah, in such case I can create getter and setter, but I still need to implement them in the implementing classes. Yeah, so yeah, in this case, we cannot really say that it is implemented. Yeah, so we need to implement, so we can't implement the members in the interface. Yeah, so do you have any questions about these points? Okay, if not, we move on to the next one. The points about the abstract class. So the abstract class can be instantiated. This is false. And this is the distinguishing feature of the abstract distinguishing point of the abstract class is that they are not created for being the objects. They can only be used as the superclasses for the subclasses. So, and they cannot be instantiated. They cannot be used as the real objects. So this is false. Okay. Second one, a class having abstract methods may not be an abstract class. This is false. So abstract methods can only be defined under the abstract class. Because otherwise, if the abstract method is defined in the real class, this doesn't make sense. Like, let's say if you declare the abstract method under the class, then you create the object from this class, you call the method, and the method has no implementation, so the compiler, the program does not understand what you want to do. In such case, that's why this is false as well. Next one, a class that has more than one abstract method. Yeah, so this was also a little bit confusing because here's the point, it has more than one. So it's not said it has one or more, it has more than one. So this is a little bit confusing, but it is still correct. Whatever declared when inherited from master class must be declared as master class. Yeah, so this is true. Yeah, so if the class has the abstract method, then it is an abstract class. Because otherwise, if the class is not abstract, the method should be implemented, so it is overridden and it's not abstract anymore. Yeah. So, but yeah, so the term has more than one. I would say this is a little bit confusing because it's enough if at least one method is abstract, then the class should be abstract. So, but yeah, that was a little bit confusing, but still correct. Then the next one, when you use an abstract modifier on a static property, it will result in the error. This is correct because abstract property means that static property means that it is not changeable. Means the behavior of it is not changeable. You cannot override static properties. You cannot change their behavior, and so they stay static. But for the on the other hand, for the abstract properties, they must be changed. Their behavior must be changed under the subclass. Yeah, so that's why they have two, abstract and static have two absolutely opposite concepts. That's why abstract property cannot be static. Yeah. So do you have any questions about this 14 point? Is there anything not clear? Okay. If not, then we can move on. Next one is given the following code, which output is correct. So we have the two classes, class A and class B. We have main method here. So let's say that, yeah, so this is body constructors. This is body constructors. What I just already shown today is that we create the object of the subclass. We assign it to the variable of the superclass. Here it doesn't matter. Here we have the upcasting. And so upcasting is done. And then the object B is created. Object B is created. Then the constructor of object B is called. This part of code is not actually needed. Even without the base calling, it would call the constructor of the superclass. And then it will call, firstly, it calls the constructor of the superclass, and then it calls the constructor of the subclass. That's why class A and class B would be printed. Yeah. And the sequence also matters because remember that when we want to create the object of the subclass, we need to create the object of the superclass. And so that's why the constructor of the superclass is first and the constructor of the subclass is second. So this is the point. Do you have any questions? And do you have any questions about the test in general? I will check on this point, yeah, because I forgot about this point, yeah, so I will check that and make a small adjustment in your results, then I will publish the full result. But do you have any questions about this? Yeah, this time it was a little bit tricky. 2 points were a little bit confusing, but 3, I guess. No, 2 points were a little bit confusing, but it's also the test for thinking a little bit as well. Okay, see, next time we get any questions you can ask, you can type once. No, that's fine. I mean, mistakes are always good, so we discuss them. And actually, the main point for the test is to summarize what you already come through, to maybe make something clear, and put some theory in your mind, and then to understand it even better. Yeah. So this is also the way how to learn. And also discuss this. Okay, I will share the answers with you then in separate, and yeah, also I don't know, also share the results. Right now, if you don't have any questions, we can make a 10 minutes break, and after the break we will discuss the potential solution for the array store discussed last time. But okay, let's have 10 minutes break first. So the meet at 48:49. Okay, let's. I think we can continue. And yeah, so as I promised, let's check if the stream is already still ongoing. Yeah, the stream is ongoing. It's fine. So let's do Yeah. So basically, the question was, yeah, how the task for the last time was how we can not adjust, but enhance the array store method. Sorry, array store class to be able to not care about the capacity. So it means that make unrestricted capacity for the class. And the idea is the following. Let me copy paste the files here. I'll maybe paste them here. I'll copy paste the files here. So that was activity 5, if I'm not mistaken. So I take array abstract array store and put it here. Oh no, let me take maybe from activity 4. Maybe no difference, but yeah. So I'll take it here. So this is abstract array store and this is array store. Yeah, so let's make some adjustments. And the adjustment would be, I would say, pretty much simple. I do not, we will keep the capacity here, but then I will not, I will maybe create a separate method which will increase the capacity. So that will be private method, private void increase capacity. So what will this do? This will change the capacity and stuff. And yeah, so basically here in abstract class we have default size, so I will use this default size. I will use this default size and I will not use the array size. Yeah, so array size will not be used here, and then I will change this one. I'll change this one. I will create the array using the default size. So I don't need them to provide the size. I will use default size, and I will use it. You'll wait around. I'll explain why. I will use so it means that every time when I create the collection of the abstract array store, it will always create the object with default size. And the size 5, I can maybe increase it by 10, so it's up to me to decide. You'll say later on why do we need this. Yeah, and then what I will use here when I want to increase the capacity, yeah, I don't have this store, I will then simply, oh no, I don't simply need this constructor anymore, since I have everything what I need, and then so because yeah, so here I have increased capacity. So what does it mean? It means that I can, so let's say I have the current capacity and I will add the default capacity then. So that would be default size. So I will increase the capacity, and yeah, so here is the point. Then here I need to change, or one moment I can then, we have the capacity, store array length. Actually this so interesting thing. Yeah, actually this is one expression. Yeah. So at this point, yeah, let's then keep it as is. But then I will maybe I will better than. Actually, there's no difference if I do it in the subclass or if I do it in the superclass. Maybe let's do it in the subclass. Yeah. Yeah, I mean, So what will I do? I will say I'll have new capacity, and this would be this capacity plus default size. So what will then I do? And by the way, in this case, I will say I will have protect. Yeah. So this is, here we go back to the question. That we need to change the access modifier for protected array. Again, remember, every time we have an alternative. If you want to change the access modifier, there is always the alternative that we declare the method. Can declare additional method, and then that would be void change, maybe replace array, replace store array. So, and here I can provide new array, and then from here I can change the store array. Yeah, so instead of, like all the time, instead of changing the access modifier, it's always better that you create the method which does it instead. And so in this case, I say that I can only change this array from the subclasses. Okay. So yeah, then I have new capacity, and then I can create the array with the new capacity. So first of all, what I do, I create this new array. So that would be new D with the new capacity. Okay, so now I have a new array here, and what I need to do, I need to then paste the object from my current parent to this array. Okay, maybe I will maybe then do it that differently. I will call this a superclass. That would be better than, instead of replacing. Yeah, I think that would be better if we did this separately. Again, this is up to you, what you designed, how you can do it, but I prefer maybe this way. If you want, you can also do everything in subclass and then change the access modifier, but maybe I prefer this way, since I have direct access to the private attribute, so it's easier for me to do this inside the superclass. Okay, so then I define it, and then next step, what I need to do is I need to copy the array. So remember, I have this array copy, and then I can copy. So the source array would be this store. The destination array would be new array, and the length would be actually simply the length of the current array. So that would be store array length. Yeah. Okay, values are copied. Or maybe not increase capacity. Yeah, okay, that will be fine. The name of the method will be fine. And then what I do, now I replace the old array with the new array. Right now the capacity is increased. So then this should solve all my problems. And yeah, so if the count is greater than capacity, I can increase capacity. So then I say increase capacity. Okay, so then I can do this. I can do this in all the cases when previously this triggered the situation when we have not enough capacity. So in this case, I can simply increase the capacity in all these cases. That was a problem. Oh no, yeah, so here I can then keep using else if, because this will be just simple addition instead of the rule. Okay, so do we have such cases? More? No, remove that. No, that will be fine. Okay, so let's then test this. Have session. Yeah, okay, maybe. So let's create a new array store. Oh, yeah, by the way, the namespace is different. So maybe I can, what I can simply do, I can use this namespace. And then I can use my array store or abstract array store as well. Abstract array store. Okay, so the data store, I can then use this here. Show data store. Okay. So I have abstract array store. So that will be my collection. Then I create the array store. And then our first type would be, let's say the type would be string. Why not? Okay, so now I have my collection and I can add as many elements as I want. So let's say I add element 1. Yeah. Okay, and then let's add, let's say, as many elements as we can. So how many do we have? I want to have more than 10. So we have 2, we have 3, we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on and so on and so on. Okay, that's 20 elements. It should be fine. Okay, let's see the results. Let's see the result if all these elements can be printed. Maybe simply print all of them. Reach. Collection. And print these elements. Oh, okay, sorry, I forgot to implement enumerable, so maybe just not implement enumerable now. I will use this way of iteration as well as the my collection capacity or count. So I guess let's use count and my collection plus. Wait, so my collection plus I plus, and then I will get the corresponding element from the collection. Get, but One moment. Oh no, this way. I have indexer. Okay, so let's run and see the results. Okay, so all the elements are added. Yeah. So this is the way how we can use the arrays and then actually have unlimited size of the elements and the ends. Yeah, by simply increasing the capacity. And as I promised, the question, why do we increase by default size? And not by simply by 1, yeah, because in theory we can do this by increasing by 1. But what's the point? The point here is that why don't we increase by 1, why we increase by default size? This is just simply because of the performance questions. If we declare the array, the initial array with size 1, then what does it mean? It means that if we increase the capacity by 1 every time we add the elements. So how this would work then? It means that we create the array, we have 1 element. I mean, we have 1 possible element to be added there. Yeah, so we add 1 element, then we need to add, if we add another element, we create a new object, increasing the capacity. So we create a new object, new array, with the capacity 2, and we copy the previous element. Then the next time we add another element, we again need to create a new array, new object that copy all the previous elements, and so on and so on. So if we increase capacity by 1, it will cost us a lot adding only 1 element. Yes, so in this case, that would be more effective from performance point of view if we increase, if our step is larger. Yeah, I mean, we can have empty spaces under our array, but we don't need to create the object every time. So here we create a new object and copy the elements every 10 elements added. Yeah, we add 10 elements, then we create new object. We add 10 elements, we create new object. We add 10 elements, we create another object. Yeah. So here we have this larger step, which prevents us to create and copy the elements every time. Yeah. So, but yeah, this would be the point we can do to simply enhance this array store to make it more flexible for the unlimited size array with the unlimited size. Do you have any questions about this? So we create new array. We increase the capacity and we create new array, copy all the previous elements, and then replace the current new array with the previous array with the new one. Okay. So do you have any questions about this?
Quick question. I think a question about main idea. Maybe I just skipped it. So basically, idea is that for now default size is 10. Yeah. But this increased capacity means that we can add more than 10 elements.
Yeah, I mean, in case we already have 10 elements inside the array, we want to add 11th element, then we increase capacity by 10. So it means that we actually, I mean, from technically, it means that we create a new array which has the size with capacity 20 instead of 10. It's not 11 just because, like, if we add more elements, then we don't need to create new objects every time. Yeah. In this case, we already then make this larger step to be able to add more and more elements. Yeah.
So for this new array, it's possible to add not limited elements, or there is limited, or more?
Not for the array, but for our particular type of the collection. For array store class, it is possible, because we use this as collection. So for our collection, it is possible, but for array, it is not possible to have a limited size, because for arrays, every time we reach the size of the array, we need to create a new array then instead and copy all the.
So it's 10 pieces for each array, yeah, basically in this case.
No, every time we increase the size, so it will be 10 for the first array, then capacity is full. We create a new array which has capacity 20. Next array will have capacity 30, and so on and so on. So each array has the increased capacity by 10. Every time.
Okay, thank you.
We simply increase the capacity. And why we need to copy? Because otherwise, if we don't copy the elements, simply the elements will not be copied. So it means that we will create the empty array. And the question for me is why we need to make a copy of an array. We don't create the copy, we copy the elements. Because otherwise, if we don't copy the elements, we'll simply, at this point, so, in this case, we simply, instead of using the current array, we create a new array which has a larger capacity. So we increase capacity. To be honest, I'm not really sure if this is the orthodox way of implementing the array lists, because I have not really explored the concept of array lists, but this is one of the options how we can do this. And this is my understanding of array lists. Maybe my understanding for the array lists is a little bit wrong, but this such way is still relevant. Because if you want, you can read more about array lists, but the concept is, I would say, it's definitely similar. Maybe there are some tricks how to increase the performance of the array lists, of the lists. So for non-generic collections, these would be the array lists. For generic collections, these would be the lists. But as an option, this would be the way. This would be the way, and roughly this would definitely is the way how the array lists are, how the capacity of the array list is increased. So, but this is the option how we can enhance our array store and make our size for our collection unlimited. Again, our arrays themselves are always limited. That's why if you want to increase capacity, we need to create a new array with a larger capacity and copy all the previous elements, otherwise we'll simply lose them. So do you have any more questions about this? Again, as usual, I'll share the code with you, so don't worry. Let's do this. Okay, so if there are no questions, then you can take time to complete activities 6, 7, or at least continue with activities 6, 7, and 8. So we can discuss them on Wednesday. I'm still here, so in case you have any questions, we can take 10 or maybe 10-15 more minutes. I'm still here, so in case you have any questions about activities 6, 7, and 8, you can ask. And so on. And meanwhile, I will correct the points we discussed from the points at one point we discussed from the notes check. Then I will also share the results with you. Okay, so then please proceed with the activities 6, 7, 8, and meanwhile I will check. I will adjust the results and then share them with you. Okay, so I'm sharing the results with you. So I'm sharing it in the. I think you can share it in the chat. So that should be fine. So yeah, in case you have any questions, please let me know. Maybe yeah, so maybe we can discuss them next time if you haven't, if you don't notice anything today. So yeah, so this is about it, and let me also share the answers for the knowledge check. Okay, so let me also push the changes into the GitHub repository as usual. This is command prompt. Okay, so and we change directory. We add the comments. Fine. Okay. Git commits. Next state is the 6 somewhere. Okay. The last we push them. It is done. No. Okay. Okay, it's done. So do you have any questions?
I have a quick question.
Yeah.
I think I didn't hear it properly. You mentioned one very good sentence was regarding lists and array lists. Yes, and I think you mentioned something regarding generic. So basically, my question is there some situations where we need to choose array list or list or it usually doesn't matter?
Yeah. I mean, for the difference is simple. For array list is not generic, so for array list you can put all the possible elements you want. So array list elements you don't have the type for them, but for the generics you do have the type. So it means that the type for like you define the type as we usually do. Yeah. So here we define the type. It means that all the elements should be string. Yeah, but for the array list there is no type, so you can put all the possible elements there. Yeah, so this is the
So basically, in one list can be only one type of element, not like string, integer, and something, but either string or integer.
Yeah. So if we have generics, collections, generic, and then if we simply use collection system collection, then for the array list we do not have any type array list. Yeah, so we can put any possible elements there. Add integer. Yeah, we can add basically any object there. Add string or any other type. And this is acceptable, but for the lists, list is the one moment. List is to what's the list? Moment. No, it's fine. It's fine. Moment. List. That was collection generics. Yeah. Let's duplicate. Yeah. So let's define the list. Oh yeah. So it is here. It's just I haven't noticed this. But yeah. So and here I can add only the strings. So this is the point. I cannot add the integers here. So this is the difference. Yeah. So all the possible types I can put into the array list, and only the type I defined I can add to the list. So this is the difference for generics and not generics. And generics is preferable because the type is controlled and it is more safe. It's safer to use generics instead of not using generics. Okay, let's see how is typing. Yeah, see any questions you can ask. So any questions you can see how is typing. What's better if you make a list with multiple data types? What is better to make a list or list and make convert example to string a list with multiple data types? What do you mean making a list with multiple data types? So how do you mean this? List with multiple data types. Example, but we cannot put integers and strings. We can do it for the array list. I mean, but for the generics, we cannot make multiple data types normally. Or you mean we can have them the maps? Yeah, okay, then you can do it. But I mean, this particular case, that would be if you convert integer to a string, this would be string. So this is. I mean, of course, this would be a better approach because you still have the strings. Even if you convert integer to string, it will still be the string. So in this case, you still work with strings. Yeah, that's why it would still be better, I think, since you still work with the same type. Yeah. I mean, it's just if you know the type, yeah. Because the problem is if the compiler does not know the type, it has less functionality. Since not knowing the type, this would mean that this would be the object type. And so it knows the only thing the compiler knows about it, that it is the object. Yeah, so it has only the properties. I know about this object, I only know that it has the properties which are defined under the object class, but I don't know any specific features what can be under the real class. Yeah, not the real class, but the class I cannot do the collection. Yeah, so with the generics, it's safer, it's more controlled, and at the end it triggers more functionality because the type is controlled. And so it means that it has the elements, they all have the same type, and then I can proceed. I don't need to pick which are integers, which are string there. I know that they all are strings, and then I can use this type with this collection. Okay, good. Any more questions? Okay, if there are no questions, then we can close the session for today. If you have any more questions, you can prepare them. We can then discuss maybe during the next session on Wednesday. Okay, so thank you very much for your attention today.